morning children. Up to we had done 2 videos on this chapter amines, and now we are going to conclude this chapter here. It's taking many days, so better to conclude by this video regarding the amines. Maybe in the last part, taking one point of view, that is regarding the basicity of amines, we have learned many concepts. Now in this session, we are going to highlight the remaining properties. You know the second chemical property. What is the second chemical property, children? Reaction with alkyl halides. Reaction with alkyl halides. We have already learned about this reaction with alkyl halides. Means any amine, like primary amine, if you react with any alkyl halide, it will form the secondary amine. And they will form the mixture of the quaternary ammonium salts they will form. So we are not going to waste our time by still stopping here. Taking the third one under consideration. Reaction with acetyl chloride. Generally you can use the acetyl chloride or acyl halides. We generally need to call it a general form. We need to call this as the acyl halides. What are acyl halides? Are C double bonded O. Any in the place of chlorine you will have any halogen like bromine or chlorine or bromine. So such kind of acyl halides once we react with the amines. Partial positive charge it will receive electrons from the nitrogen that results in the formation of N. I am not writing the step by step. R and H, C double bonded O, R dash. What are formed, children? Amides will be formed. What will be formed, children? Amides will be formed. This is in the case of alkyl halides. The similar will be if you take aliphatic amines, you can do the same method, or you can take the aromatic amines. They also will follow the same kind of reaction. But our main fourth property is regarding our carbyl amine test. Carbyl amine test means our primary amines, especially our primary amines, once we react with CHCl3, it is called as trichloromethane. In presence of potassium hydroxide, they will form N triple bond C. What is the product here? It is called as an isocyanide. Foul smelling compounds. What are they? Foul smelling compounds. We want the main point. We don't want the byproducts. This is not used now. We want the main products. What will be formed? Isocyanates. What is the smell? Foul smelling compounds. So that's what we have learned up to the fourth property. But coming to the fifth property. What is the fifth property? Reaction with nitrous acid. Fifth property is the reaction with nitrous acid. Reaction with nitrous acid. Generally, this nitrous acid formula is HNO2. But it is formed by the reaction of NaNO2 in the presence of 2 moles of hydrochloric acid. NaNO2 in the presence of 2 moles of hydrochloric acid. So, whatever is there, amine for you, amine. I am considering an aliphatic amine. Once we react this mixture of sodium nitrite and hydrochloric acid, so you can find an intermediate that will be formed here, CH3, CH2, N2 plus Cl minus. These are forming the intermediate compounds called diazonium salts. On hydrolysis of this diazonium salts, the major product formed here is ethanol. And nitrogen gas is evolved. Along with that, HCl will be formed. So by the formation of the amount of nitrogen gas, these are used to determine the proteins and amino acids present in the compound. Determine the proteins and amino acids present in the compound. So this is what about aliphatic amines. Aliphatic amines, how they react with this nitrous acid. HNO2, from where we are getting this HNO2? We are getting this HNO2 from the mixture of sodium nitrite and hydrochloric acid. The fifth one is very simple in case of aliphatic. The same you need to follow regarding with aromatic. The same you need to follow regarding the aromatic. What is aromatic, children? Benzene, like aniline, when reacted with this nitrous acid, NaNO2, in presence of hydrochloric acid. This is also going to form an intermediate, N2 plus Cl minus. We call this one as the benzene diazonium chloride. What do we call this one as the benzene diazonium chloride? So a topic is there that is related for PUC, but today we will highlight the topic about the benzene diazonium chloride. So shall we work with the benzene diazonium chloride first? Yeah, we are working with all the reactions of the benzene diazonium chloride, and then we will switch back for the normal sixth property. Like one more test is there, Hinsberg reagent. Or let me finish the Hinsberg reagent, by that it can be stopped there. And special I will work with that. Means up to here for CET it is useful. Then later part will be useful for neat. Hinsberg reagent. Benzene sulfonide chloride. Benzene sulfonide chloride is called as a Hinsberg reagent. What is the formula of benzene sulfonide chloride? Benzene is there. Yes, double bonded rose is there. Cl is there. It's called benzene sulfonide chloride. It is used to distinguish between primary, secondary, and tertiary amines. Primary, secondary, and tertiary amines. Very important concept. Primary amines means what? Nitrogen is having two hydrogens. It's called as the primary amine. What is meant by secondary amine? Secondary amine is having only one nitrogen. But tertiary amine does not have any hydrogen. Tertiary does not have any hydrogens. This is secondary. So once you react the Hinsberg reagent with this amine, primary amine, it is forming sulfonamides. They will form the sulfonamides. These are the class of drugs, antibiotics you can say, sulfonamides, antibacterials. It's a sulfonamide drug. Here the pointing it out is, once you further react this with a base, this is having, which is having the intermediate sulfonamide, what I am calling, it is having the nitrogen bonded to SO2 group. SO2 is an electron withdrawing group. It withdraws electrons from the nitrogen, parallel nitrogen withdraws the electrons from hydrogen. So this is what we call as the acidic hydrogen. So which will have acidic hydrogen means primary amine will have the acidic hydrogen. Due to this acidic hydrogen, this intermediate sulfonamide is soluble in the base. It is soluble in the base due to the presence of this acidic hydrogen. But if you react the benzene sulfonide chloride with our secondary amine, the intermediate formed here does not have any acidic hydrogen. It does not have any acidic hydrogen. So due to lack of this acidic hydrogen, this is insoluble in the base. It is insoluble in the base. That is added here. Generally, potassium hydroxide we will be adding here. Potassium hydroxide solution will be adding. From the potassium hydroxide, we will be having OH minus ions. So this is insoluble in the base. So very important point. Reagent names you must remember. Good. So by this we are able to conclude here regarding the chemical properties. And well familiar, you know the electrophilic reactions of this aniline. Electrophilic reactions of this aniline. Children, every property we cannot explain now. Those are already explained in the class. Please read. I will explain only one property here. That is the first and foremost very important property regarding, what is it regarding? Aniline electrophilic substitution reactions. Electrophilic substitution reactions. Electrophilic substitution reactions of aromatic amines. See, generally this aromatic amine aniline is having NH2. NH2 is an electron donating group. It is an electron donating group. Means electrons will be given to the ring. Hence, electrophilic substitution reaction takes place at ortho and para positions. Where do the electrophilic substitution take place? Ortho and the para positions. So initially we are reacting this with bromine water. Wherever you get bromine water, blindly you give. The product is called 2, 4, 6. What is the product called, student? 2, 4, 6. Here we start 1, 2, 3, 4, 5 and the 6. 2, 4, 6. Tribromoaniline. So that's what the point to study. And then you can understand here one more point. But how we had reacted amine with acetyl chloride. Similarly, we can get only one bromine substitution. Once we react our aniline, in the presence of acetic anhydride. This is called as the acetic anhydride, children. So acetic anhydride will be giving electrons will be given for the acetyl group that will protect the nitrogen. From the bond formation. So once you add the bromine in presence of ethanoic acid, you will not get all the three substitutions. You will get a substitution of bromine either at the para position or either at the ortho position. Here, para is major. Because at ortho, the bromine cannot be attacked due to the bulky group of the acetyl group bonded to the nitrogen. So keep in mind, acetyl group or acetic anhydride group that helps in protection of nitrogen. You can read now, or the textbook also you have very clearly given how does the aniline reacts with nitration mixture. Aniline reacts with nitrogen mixture to give different products. In the first step, how we had got HNO3 in the presence of H2SO4, that will give NO2 plus ion. Is it not? Nitronium ion will be given. I am not showing the steps here. Nitronium ion, generally, the first thing everyone will think, nitronium ion is an electrophile cell. So compulsorily nitronium ion will be bonding at different places, no sir. Maybe at the ortho position or maybe at the para position. Maybe at the ortho position or maybe at the para position. You know here it is around only 53% and here it is only 2%. 52% there we get 52 or 51%. Para nitroaniline product is 51%, whereas the ortho nitroaniline is only 2%. Then how much of percentage is missing? 47% is missing, right? Who is forming at 47%? The aniline, once you see, the aniline having the nitrogen, the lone pair, the nitration mixture, before it is formed, see the nitric acid or the sulfuric acid, what do generally the furnish the H plus ion. So this type of another product is also there here. Means the furnished H plus is readily accepting electrons from the nitrogen, that is forming the enilinium ion. That is forming the enilinium ion. Enilinium ion. But this enilinium ion is an electron withdrawing group. It is an electron withdrawing group. Hence, electrophilic substitution. See, electron donating group favors the electrophile towards to ortho para, but electron withdrawing group favors the electrophile to meta position, towards to meta position. So the nitrogen that is generated in this reaction, it is directed towards to the meta position. Directed towards the meta position. Keep in mind, very important area. So along with these two, means once you react aniline with the combination of nitric acid and sulfuric acid, orthonitroaniline, paranitroaniline, along with this one, what we are able to get? We are able to get the meta-nitroaniline. Meta-nitroaniline. And this is around 47%. 47%. So up to here we learned in the normal PUC. And up to this it is useful for the CET. But now the deleted syllabus, they are going to learn the deleted syllabus, that is very important for the objective examination point of view. See children, at the end of this concept, there are the textbook examples. You must read the textbook examples also, because in CET they are giving in a direct manner. They are giving a direct equation how it is done in NCR textbook. So you please practice the NCR textbook examples also. Presently my concept is regarding diazonium salts. My concept is regarding diazonium salts. This is not there for CET. It is there only for NEET. So CET students who are writing CET, no need to touch the area. But you are writing NEET, you must read this area. We have already brought this point. What have we already brought this point? Benzene on reaction with arene in the presence of NaNO2 and 2 moles of HCl. What was formed, children? N2 plus and Cl minus. What did we call this one as the benzene diazonium chloride? We call this one as the benzene diazonium chloride. See, if the starting material means this is the reactant. This is the reactant we have. Now you are reacting the benzene diazonium chloride. I am bringing all the reactions at one place, children, instead of wasting the place and time. Cu2Cl2 in the presence of HCl. Basic thing is, benzene is a nucleophile. You cannot bring another nucleophile near to the benzene. In order to bring another nucleophile onto the benzene, we are going through this method. Which method? Formation of the benzene diazonium chloride. And hence we can get here, even in this case, H plus and Cl minus. We are bringing the Cl plus. In these reactions, what are the intermediate forms? Intermediate form will be Cl plus. We can bring the chlorine using this mixture, chlorobenzene. If you use Cu2 Br2 in presence of hydrogen bromide, you can introduce bromine here, bromobenzene. It is of example bromobenzene. If you react with copper cyanide in the presence of potassium cyanide, it is going to form cyanobenzene. It is going to form cyanobenzene. Or if you react this with potassium iodide, it will form iodobenzene. It will form iodobenzene. See, this entire path that we have written from here to here, it comes under a named reaction called Sand-Meyer reaction. What is the name of the reaction? These all are under called Sand-Meyer reaction. Sand-Meyer reaction. Now there is an interlink with chapter number 10. After this, it is continued like if you react the benzene diazoxide chloride with copper in the presence of HCl, then also chlorine will be introduced. If you react the benzene diazoxide chloride with copper in the presence of hydrogen bromide, then also bromine can be introduced. So these reactions we are calling as the Gattermann synthesis. What is this one called as the Gattermann synthesis? These are the named reactions. Other than this, we have many. Shall I continue here? Very good. I am continuing here. So let me say, if the reactant, so you people are habituated to see the names only towards left to right now. You know this, you can copy from textbook. Now let me continue my concept here like benzene diazonium chloride. Benzene diazonium chloride, if reacted with a simple reactant, fluoroboric acid. Its formula is HbF4. What is formula, children? HbF4. See, the benzene diazonium chloride reacting with this fluoroboric acid. Imagine here nitrogen is there. It will be there as usually. It is forming some intermediate. Chlorine is removed along with hydrogen, and it is forming some intermediate. This intermediate that is formed here comes with two reactions. One reaction is, if you heat this intermediate, fluorine is introduced onto the benzene. Introduction of fluorine onto the benzene. Once you react this intermediate with NaNO2 followed by hydrolysis, NaNO2 sodium nitrite followed by hydrolysis, it is going to introduce nitro group onto the benzene. Okay, children? So fluoroboric acid, once you react with benzene diazonium chloride, it forms an intermediate. If you heat it, it is taking place with introduction of fluorine only. If you react with sodium nitrite and water, it is forming the nitrobenzene. I am not writing the names because you are remembering the names. But if you do only a reaction of this benzene diazonium chloride with the orthophosphoric acid, H3PO2, very important for JEE mains. H3PO2 followed by hydrolysis. This will be oxidized. Means it will be converted to H3PO2. Here on the benzene, the entire groups will be removed here and hydrogen will be introduced. Means it is reducing it into benzene. And a similar type of reaction you can see if you react that with ethanol. And in that case also, what will you get? Benzene. These two reactions are very important for JEE mains. Okay. Now let us see. If you simply hydrolyze the benzene diazonium chloride, that will form phenol. What is it going to form? It is going to form the phenol. So these are the different reactions of the benzene diazonium chloride. All the raw material is the same, benzene diazonium chloride only. But when the reagent is changed and the condition is changed, product will be changed. Okay, children? At last, there is one small concept that's called as a coupling reaction. What is the one called as the coupling reaction? So that is also useful for neat, not for CET, as it is a deleted portion for CET. Coupling reaction. What is coupling reaction? What is coupling reaction? What is meant by coupling reaction, children? Coupling reaction means once we clearly observe this benzene diazonium chloride, N triple bond N Cl minus. If you react this with phenol, from here one hydrogen and here chlorine will be removed. They are going to form a bond between the nitrogen completely. Between the nitrogens will be there as usually, and there will be, see here, negative positive charge will be there, but once it is removed, only double bond can form there. It is having a bond with the benzene ring. It is having a bond with the benzene ring, and OH is there. Ortho, meta, para. What do we call as the ortho, meta, para? So this part I am calling para, hydroxy. Two nitrogens are paired there now. We need to call azobenzene. What is the name of this one? Para-hydroxy azobenzene. It is an orange color dye. Coloring compound. And if the starting reactant is benzene diazonium chloride, okay, and you can see with one more reaction here. What the one more reaction means? If the reactant, another reactant is aniline, then the formed product will be different. What will be the formed product, children? Para-amino azobenzene. Here it is an yellow color dye. This is what entire topic regarding the concept amines. In the last video we had done some concepts along with questions. In this video also we are going to see some questions now. And now it's the question hour round for us to learn. The question is there on the board. Can you read it? Good. What is the question? In the following sequence of reactions, A gives rise to B. How the A is giving rise to B? By the reduction process. B on reaction with HNO2, it is giving CH3, CH2OH. What is the name of this one? The name of this one is called as the ethanol. And now we need to find out the A. We need to find out actually the A. It was asked in 2016 CET. How these type of questions we can answer? The first thing is we must not give up about the reagents. You must take a back step from the C to B. Then you can go from B to A. Because there are the options like ethanol, you got it. And what are the reagents used here? HNO2. How can we get HNO2, children? We can get HNO2 using NaNO2 in presence of HCl. Then followed by hydrolysis only, we got this ethanol. From where? Do you remember last point I have called for you? Ethane amine. From the ethane amine on reaction with NaNO2 in presence of itself followed by hydrolysis, we got the ethanol. That is the only source. Then HNO2 means only this amines chapter. Okay. Again, this front part, what is there? A carbon chain is there. Alkyl group is there. So the alkyl group means we can know the same name. How can we get alcohol? Means we can get the alcohol when an amine is there, and that is treated with the NaNO2 plus of HCl. But now we don't know what is the A here. What is the A? See, reduction. Reduction is 2 points we can remember. One is NO2 can be reduced to NH2, and second thing is N triple bond C, it can also be reduced to NH2. These are the two options that are in front of us. So the A can have NO2 group, A can have NO2 group. If it is having NO2 group, then it may be its formula. If A is having how many carbons are there here? Only 2 carbons. No? if A is having CH3, then this is the chance. Is it not? Not CH3. Yeah, we can have the CH3. How many carbons are there? 3 carbons are there. No? So then we can have CH3, CH2. CH3, CH2. So, form this type of reactions. Whenever you have reduction, you will have only two options. Either the nitro group will be present or nitro group will be present or isonitride will be present. So, A will be nitroethane or ethane nitride. Ethane nitride. So, find out your point out here. How to work out this fix? Go carry on all the 4 options where you are able to find. See, propane nitride. What are they suggesting? Propane nitride, ethane nitride, nitromethane, and methyl isocyanate. Find out the correct option. Give a name for that. Then you will get the answer. See the second question. An organic compound A on reduction gives compound B, which on reaction with CHCl3 and KOH forms C. An organic compound A on reduction gives B, on reduction gives B, on reduction gives B, which on reaction with CHCl3 and KOH, CHCl3 and KOH forms C, forms C. The compound C on catalytic reduction gives, compound on catalytic reduction gives N-methyl benzene amine. N-methyl benzene amine means what? It is forming NHCH3. What is it forming? NHCH3. Most of the children will be expecting, sir, this type of questions will be given. Yes, this type of questions only will be given. You must find out the A or B or C, what they will ask. Gives C. Okay. On catalytic reaction gives C. Find out A. We need to find out the A or the raw material A. Many options are there. Nitrobenzene is there, nitromethane is there, methane amine is there, benzene amine is there. So how to get this one? You can know one point here. Instead of taking directly to A, one switch back to the C. One switch back to the C. C on reduction. C on reduction. We got this product. What is suggested for you? CH NHCH3, NH2CH3 also. We can get here isocyanate is there, no? N. If the C is having N, triple bond, N, triple bond, C. Some isocyanate group is there. Then only we can form this NH2CH3. Then only we can form this NH2CH3. See here in the above reaction, what we had done? We had learned that if nitro group is there, it can be reduced to NH2. Even if we have cyanide like C triple bond N, this can also be undergoing the process of reduction. This is there, ethane nitride is there. What is the name of this one? It is called as the ethane nitride. If you reduce this ethane nitride, what product will be obtained? CH3, NH2 will be obtained. So please keep in mind, children, if nitrides if you reduce, you will be getting a carbon and NH2. If you are reducing isonitride, then nitrogen followed by carbon will be there. So in the above question, I hope I had given an answer now for you. Is it not? You can check the starting material what is suggested here in the above question. We got ethane amine. Where is this one? From the B, we got this ethanol. B is called ethane amine. How did we got ethane amine? By reduction of ethane nitrile only, we got ethane amine. If isocyanate is there, Isocyanide on reduction, what will get? NH2CH3. Some R NH2CH3 is there. So now we can now predict this R is nothing but the benzene ring. R is nothing but the benzene ring. Now I am working with this C. R is the benzene ring here. R is the benzene ring. Benzene isonitrile is there. How did we got this one? You can see CHCl3 and KOH. CHCl3 and the KOH. What is the reagent name here? Carbylamine test. Yes, carbylamine test. Amines, maybe aliphatic amine or aromatic amine. Aliphatic amine or aromatic amine. When reacted with this carbylamine reagent, they will give the isocyanates. Now A on reduction it is giving to B. A on reduction it is giving to B. See here children, what I suggested, whenever we have a nitro group on reduction, that will be converted to NH2 group. Very important example here. If it is nitrobenzene, you can use tin in the presence of HCl, or you can use Fe in the presence of the HCl. Reduction goes on to form the NA. So this method of reverse reaction must come up. So what will be your option? Your option will be nitrobenzene. A is what? The starting material A is what? Nitrobenzene, nitromethane, methanamine, benzene, amine. If they are asking the A, so A is the nitrobenzene. See one more simple question, children. A mixture of methylamine and dimethylamine. What is the formula of methylamine? CH3 NH2. What is the formula of dimethylamine? CH3 NHCH. This is the secondary amine. And this is a primary amine. This will be the main points to be studied. How can you distinguish between a primary and the secondary amine? See the option A, CHCl3 and HCl. We don't have any reactions of these. If you see C6H5SO2Cl and KOH, this compound is nothing but it is the Hinsberg reagent. What is this one? Hinsberg reagent. Yes, when you react Hinsberg reagent, primary amines are soluble in the base. That is called potassium hydroxide. Whereas secondary amines are insoluble in the base. By this we can distinguish the primary and the secondary amine. Or we can distinguish between the methylamine and the dimethylamine. So whenever any name is given, first you write it in the form and try to find out which kind of amine is that, and you can get the reagent that is used to distinguish between them. See children, we got one more question here. The question is, an aromatic compound A on reacting with NaNO2 in presence of HCl forms benzyl alcohol and nitrogen gas. The number of possible isomers of AR. What we can find out is, only this NaNO2 in presence of HCl. NaNO2 in presence of HCl. We can understand that the reaction takes place at 0 degrees Celsius or 273 Kelvin. It is forming benzyl alcohol. What is the formula of benzyl alcohol, children? Benzyl alcohol formula is CH2OH. This is called as the benzyl alcohol. They will not mention for you. What they will not mention, the water molecule, they will not mention this reaction. Along with this, what gas is formed? Nitrogen gas is formed. So please don't forget, this is the alcoholic part. Last session we brought one reaction CH3 CH2 NH2 when reacted with NaNO2 in the presence of HCl at 0 degrees Celsius. What was formed, children? CH3 CH2, OH was formed, and the byproducts will be nitrogen gas, and that is used for estimation of the proteins and amino acids. Proteins and the amino acids. Is it not? Yes, that is the point to be studied there. And now our case is here. Product is benzyl alcohol. What is the difference between ethanol and the benzyl alcohol in the structure? You can find. You can find here CH3 is there. Here benzene is there. That's the only difference. Means what will be the starting material now? Starting material, can you guess? The starting material of the reaction will be in the place of CH3 we got benzene. So CH2 NH2 CH2 NH2. What is the question they are asking? They are not asking what is A. They are asking how many number of isomers are possible. How many number of isomers are possible? If you elucidate the formula, 6 carbons are there here and one more carbon. Totally 7 carbons are there. On each carbon here 5 hydrogens are there and here 2 hydrogens are there. Totally 5 hydrogens here, 2 hydrogens and 2 more hydrogens, totally 9 hydrogens and the nitrogen, and that is fitting into the formula given. And now the questioning is how many number of isomers are possible. Let me say this is first of the isomer possible. C7H9N is there, good. This is the one of the isomer. Already we got the isomer. And second kind of arrangement, how should we bring? Isomers means molecular formula will be the same. Molecular formula will be the same, but arrangement of atoms will be different. Can I put in the nitrogen friend? And can I put write it as the NCH3? NH I brought, CH3 I have forwarded next. What are the next possible isomers we can have? Can you put write it like a methyl benzene? Methyl benzene. Orthomethyl aniline. Sorry, orthomethyl aniline. Or we can have the NH3 at the meta position, or we can have NH3 at the para position. NH3 at the para position. So again, you don't think here meta and ortho because it will be repeating in the middle images of this. So how many isomers we got today? We got the 5 isomers. We got the 5 isomers. So some questions I will be uploading in the WhatsApp. You try them doing. If you don't get, I will explain for you. Thank you.